Welcome to a lesson with Dr. Powell. Let's look again at the derivative of x to the n, but we're going to let n be anything right now. Negative number, positive number, fraction, irrational number like pi, just anything. Can we still find the derivative of this thing? Does it still follow the basic rule, n times x to the n minus 1? Well, let's just try it out for a minute. Let's rewrite x to the n in this way. We're going to rewrite x as e to the natural log x. Should make sense because e and natural log undo each other if one's inside the other. So this is equal to x to the n. Okay, now let's proceed with a limit. The limit as h approaches 0 of e to the n, and let's put this n, let's rewrite it like n natural log, like that. So in other words, let's rewrite this as e to the n natural log x. Okay, so then we have x plus h, and then let's subtract, let's see, e to the n natural log x, and put this all over h. And let's investigate this limit a little bit here, see what we can come up with. All right, we're going to try to locate maybe a derivative popping up in this limit or two or something like that as we proceed. Okay, so first we we're going to factor out an e to the n natural log x out of the top. So let's do that. And when we do that, it's going to look like this. You can get an e to the n natural log x plus h minus n natural log x minus 1 times e to the n natural log x. Now, why is that? Well, let's see. If we multiply this in, let's just double check. If we multiply this in, we're going to get that, of course. Multiply it to here. Now, think about what happens. We're going to be adding exponents. This is going to add to that and cancel out, so we're going to be left with this. So if you think backwards, it should make sense how we can rewrite this in this way when we factor out e to the n natural log x. Okay, set that all over h. Okay, next, let's rewrite. Next, we're going to rewrite this part right here as using a property of logs, factoring out the n, and then we have natural logs with the subtraction. We're going to get x plus h over x. And then we have minus 1. And for now, e to the n natural log x, let's just rewrite that. We know that is equal to x to the n, because that's what we had before. If you put the n up there, e to the n natural log cancel each other, so you have x to the n. So let's just rewrite that as x to the n. And all of this is over h. Now, notice something. See this, as h goes to 0, this inner part's going to 1. Natural log of 1 is 0. So it looks like you have e to something that's going to 0 minus 1 over something else that's going to 0. It'd be nice if we could kind of relate what's happening here to what's happening down here. In particular, what would happen if so what are we missing? Okay. It'd be nice if we were to multiply. So we're going to multiply top and bottom of this fraction right here by n natural log x plus h over x and n natural log x plus h over x. How does that help? Well, we know this is going to 0. We know this is going to 0. And this looks a lot like the limit e to the u minus 1 over u as u goes to 0. And we saw that in another video that this right here ends up going to 1. And that's actually according to the definition of what e is. So we know already in the limit since this part's going to 0, that this part that I'm circling goes to 1. Then we're just left with the rest here. So let's investigate that. And let's use property of logs to rewrite that again, keeping the n out front as natural log of x plus h minus natural log of x. And then we have this all over h times x to the n. That's what we have right now. And notice that this part right here looks an awfully lot like the derivative of natural log, which we computed in another video to be 1 over x. Oh, beautiful. So this tells us that the derivative is n times 1 over x times x to the n. Think about exponents, n and 1. So this would turn out to be n times x to the n minus 1. Bravo! The rule works in general for any n at all. We had no restriction on n being an integer or anything else. So we have the power rule for derivatives for any n at all. Thanks for watching.